Linked list cycle. Given the head of linked list determine if the linked list has a cycle in it. There is a cycle in the linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, position is used to denote the index of that node that tail's next pointer is connected to. Note that position is not passed as a parameter. Written true if there is a cycle in the linked list, otherwise written false. So, exactly what is this question saying is that we have to return true if there is a cycle, and if there is no cycle, then we have to return false. So, for example, if there is a no cycle, then the nodes, first of all, linked list has a reference and a value. Reference is the node and value is the value of that node itself. So this is one kind of a linked list, and linked list always starts with the head by which we can we can traverse the linked list, and always end at the tail, which is again followed by null pointer, so that we understand the tail is always at the pointing towards null, means there is no cycle in that particular linked list. But if you observe one of the linked list in this format, like, so if you observe this kind of a linked list where you see a cycle, then you have to return true. Now, how to do this? First thing first, if you see, let's talk of the first cycle, right? So head is the node by which you can traverse the linked list. So usually, if you traverse this linked list and go from head dot next, head dot next, head dot next, and then come to null, that means there is no cycle because the tail is pointing towards the null. But if you are coming down to the next cycle which I have drawn, you see this is the head. So let's name this as A, B, the, this as B, this as C, D, E, F, G. This is the one. Okay. So if you see the second cycle, A is pointing towards B, B is pointing towards C, C is pointing towards D, D is pointing towards E, E pointing towards F, F pointing towards G, and G is again pointing towards D. So if you see, and again from D, again it will point towards E, again it is pointing towards F, G, and G is again pointing towards D. So this is a never ending process, and there is a cycle because it is revisiting this particular node again and again. It is revisiting the node again and again, and that's why there is a cycle, and we have to return true for this particular second linked list. Now, how to solve this how to solve this particular problem to understand whether this is a linked list or not. There For this particular problem, we can use a hash set data structure wherein we can see the nodes whatever we have seen. For example, if this is a hash set, if I'm solving for the first example, right, let's take this as A, B, C, D, right? Then first of all, I'll check my hash set is empty, then add the linked list in my hash set. I will be adding A in my linked list. Then next thing, I will check again, next head dot next is B. Is B in my hash set? No. I will be adding A. Next, I will be checking B. Is B in my hash set? No, B is not in my hash set. So again, I will add B in my hash set. Next, head dot next is again C. Is C in my hash set? No, I'll add C in my hash set. Then head dot next is D. D, I will add D in my hash set. And afterwards, D dot next is null. So there is no way I am repeating any node in this hash set, and hash set has all single nodes, and there is no repetition in this linked list. So I will be returning false because I'm not observing any node which is repeated over here in this asset. Let's take use this asset same for the second example. How we can do is, So in the second example, first I'll visit the head A. My hasset does not have it, so I'm adding the A over here. Then I visit B, that is head dot next. I will add B in my hasset, it's not there. Then I'll add C in my hasset, then I'll add D, E, F and G, and from G head dot next again I will see it as D, right? And I observe that my hash set already consists of D, so I won't be adding inside the hash set. Instead of that, I will be returning true, that my hash set contains that particular node, and thus there is a cycle. So we are using this hash set to store the nodes and to check whether that nodes are repeated or not. That's the reason we have to use the data structure hash set. And time complexity is O of n, and space complexity is also O of n, because and we are using hash set, so space complexity is O of n as well. But the same problem can be solved with space complexity of O of 1. How to do that? Let's optimize this little bit, the solution. Let's take this first example itself, that is A, B, C, D, and this is towards null, right? This is what I said. Then A, B, C, D, E, F, G, and again D. So these are the pointers. So here there is something called a slow pointer and a fast pointer. Okay, there is something called a slow pointer and fast pointer. What are these pointers? These both pointers are pointing towards the head. Slow and fast both are pointing towards the head, and slow always jumps to the one position, and fast jumps to two positions. Slow jumps to one positions, and fast pointer jumps for two position. That is how it is, how these pointers are, how these nodes are, slow pointer and fast pointer, these list nodes. Slow pointer also, this particular solution which I'm showing is called as Floyd's tortoise and hare solution, wherein there are two point list nodes, slow list node and fast list node, and both of this list node are pointing towards head. The only difference is slow will always move with one position and fast will move with two position. So let's see how can we confirm with this that slow that there is a cycle or not in the linked list. Let's see that. So first, slow and fast are pointing towards A. Next, slow will be pointing towards B, and fast will be pointing towards two steps, right? It will take two steps, one and two. So fast will be pointing over here. Next, slow will be coming to slow dot next, and fast will be pointing towards fast dot next, because fast is always taking two steps. And here we observe that fast came to a null pointer. It's pointing towards null, so we conclude that there is no cycle at all, because fast came to null position. Are you getting what I'm trying to say? So here in the first case, slow took a first step and fast took two steps. And at as in when we are traversing, we understood that fast is pointing towards null. So we concluded that there is no cycle in the first linked list shown. Let's take the second linked list. Here I would like to use some color so that I can show you the difference. So slow and fast. Slow and fast are pointing towards A. Now the fast will be, let's take the slow first. Let's take the green color so that I'll, okay, blue color for the slow. So slow is going to move one step. So slow will be B, and fast will be moving towards two steps. That is, B is one and C is two. So fast will come over here. Fast will come over here. This is fast, okay, because I wanted to have a color difference. Now next, slow will again come over here, right? So let's take another color again. That's the blue color, right? So slow will come over here. and fast will move towards two steps. Fast will move towards two steps. So fast, let me just write it because this is taking long time, I think so. So fast will move towards two steps. One, two. So fast is over here. Again, this slow is this side, right? So slow will come at this step. Correct? Now fast will again take two steps. One and two. So fast will be over here. Again, slow will be taking one step. So slow comes to E. Fast will be taking two steps. One and two over here. Slow will be coming over here. Fast will become taking two steps, one and two. So if you see, fast, slow, and fast are coming to one cycle again. If you see, slow and fast are coming to one cycle again. Let me show you one more time because I think this is little crazy. A, let's take second example. B, C, D, E, F, and G. I think now this is much more clear presentation than the earlier one. So we have slow and fast pointer, slow coming to the first step, fast coming to two steps, right? So one and two. So fast is over here. Next, fast will go, next slow will come again to C, and fast will move to the next step. Two steps, right? Two steps. It's moving to the two steps, one and two. So fast is coming over here and slow will be over here. Now fast will be one and two. So it will be over here. And slow at the same time, slow will take one step. So if you see, slow is behind the fast, right? Again, fast will take two steps, one and two, and slow will be over here. Again, see, you are watching the cycle, right? Again, fast will take two steps, one and two, and slow will be coming to the next step. If you observe, there is a point where fast and slow are coming together, where fast and slow coming together at one point. At that time, we have to analyze that there is a linked list cycle. You observe, right? On there, I did a couple of times cycles with slow and fast. You can also see it. And at some point of time, fast list node and slow list node come together. That time we have to take a decision. We have to conclude to a decision that this is a linked list cycle, and this algorithm is faster, or there is no space complexity because we are not using any hash set. These are just list nodes, so the time complexity is O of n because n are the nodes by which we are determining whether there are cycles or not, and space complexity wise it is O of 1. And this is a best solution for linked list because we are not using any data structure of hash set. Though we are traversing the list nodes, we have to traverse it to understand whether the cycle is there or not. But as in the space complexity wise, there is no we are not occupying any space, so it's O of 1 space complexity. Let's do the solution. So as I showed you, public boolean, right? We have to check whether there is linked list cycle or not. Let's note head. So there are two list nodes. One is slow. I will be assigning slow to head, and another list node is fast. That also I will be assigning it to the head. Next thing, one thing I didn't told you is related to the null pointer. When to stop it? See, if there is a cycle, you're not going to stop it. You're just going to go again and again in the cycle, and there will be a point when fast will be equal to slow, right? But what if there is a null? That time, what will happen? So, whatever we have drawn in first A, B, C, D, and the null. This one was my first linked list. At that time, when slow and fast both are at the same pointer, that is at the head, right? These are at the head. So slow will move with one step and fast will move with two steps, one and two, that is the fast. Again slow will move here and fast will move with two steps, one and two, that is the fast. So we are concluding that there is no cycle when fast is at the null position. But what is another linked list? These are the four nodes. That's why we are saying that if fast is pointing towards null, then we are assuming that it is a there is no cycle, right? But another way of presenting the linked list is, what if there are one more node over here in between this? What if there is one more node? What if there is one more node E and there is null over here? Then if you see, if you just rub this and do it again, the slow and fast, I just wanted to mention that point. I don't want to forget it. That's the reason I'm doing this. So slow and fast over here. Now see, slow will be moving here, fast two steps, fast came here. Slow will be moving here, fast two steps, fast is coming over here, right? Then fast dot next is null, right? At that time also we can conclude that it's a null pointer. So there are two ways to conclude, sorry, not null pointer, there are two ways to conclude that there is no cycle. What are those two ways? Once when fast itself is pointing towards null, or next one is when fast dot next is also pointing towards null. So in these two cases, in these two, if either of the cases there, then we have to say that there is no cycle at all. That is what we have to mention in our code. So while, sorry for disturbance, while fast is not equal to null, or fast dot next is not equal to null, when these two cases are not null, then what we are doing it, we are assigning, we are moving slow by slow dot next by one step, and we are moving fast by two step, fast dot next, and we are concluding it is a cycle only when slow is equal to fast, then only we are concluding that there is a cycle. If 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 this is not slow equal to fast is not happening, and if fast is coming to a null position, then we are saying return false, right? We are saying return false when fast is equal to null or fast dot next is equal to null. So we are returning false when we are coming out of this while loop, because see, while loop, we are solving this while loop only when fast is not null and fast dot next is not null. But we if it is null, if one of the two cases is valid, then we are returning false. And always, I just wanted to explain one more thing. Always the ordering of writing this should be in this fashion. It should not be like fast dot next is not null and then you're writing fast is not null. It should not be other way round, because always you have to check whether first node is null or not and then check the next. You cannot check vice versa. So please be sure about the ordering of writing this while loop. And time complexity wise, it is big O of n, and space complexity wise, it is big O of one space, because we are not using any data structure over here. So space is O of one, and that's it. And this is the way we can solve this linked list cycle. Thank you for watching.